My name is Haley Williams. I'm going to show you how to balance this and figure out the weight of your solution. First thing you want to do is zero this out. The weight of this is 29.38 grams. Now we can fill this with solution and find the weight of that, subtract, find the weight of the solution. Zero this back out. The beaker plus the solution, in this case it's water, is 55.445. So the mass of the beaker was 29.2363 grams, and the mass of the beaker in the solution, which was water, was 55.3914 grams. So we can take the mass of the beaker and the water and subtract from it the mass of the beaker. And we get that the mass of the solution is 26.1551 grams.
My name is Raghu Costa, and I'm a freshman at UAB. And today I'll be sharing how to use a balance to measure stuff, basically. So the first thing you need to do is you need to tear the balance and make sure that all the digits read 0. And then I weigh the beaker in the balance, using the balance. So the weight of the beaker is approximately 29.096. And then the last digit is uncertain because the weight can't exactly precisely measure the beaker. So 29.096 grams is the measurement, how much the beaker weighs. Next, I'll get my sample solution. This is my sample solution, dihydrogen monoxide. And next, I will re-tear the weight, get it all to 0, and then weigh my sample. Now, the weight of the beaker and the solution is 71.075 grams. Now, to find the weight of the sample solution, we would subtract the weight of the beaker and the sample from the weight of the beaker, which would be 71.075 minus 29.096, 41.979 grams. And that is the weight in grams of our solution.
My name is Catherine McKernan, and this is how to balance. This is how to weigh something on a balance. First, we have to re-zero the balance to make sure it is 0 before we add anything to it. Next, the beaker goes on. Now the digits keep changing because they are uncertain, because then the measurement is actually so small that the balance can't even read it exactly. When it finally settles down, we record it. 29.081.20. Next, we get the sample. Also, retare again, and balance again. The mass of it with the sample is 65.522. Next, we subtract that from that. 65.522 minus 29.0820, and that is 36.44, and that is the mass of the sample alone.
So for our water samples, our mass initial for the first sample was 29.0282 grams. The mass final was 65.522 grams. For our second sample, the mass initially was 29.096 grams. The mass finally was 71.075 grams. For the third sample, the initial mass was 29.2363 grams, and then the final mass was 55.3914 grams.